All right. So, a couple of things before we get going here. Um, so that quiz that we did in class that was due before we started today, class periods ago, I'll get the grades update. I said I was just going to give everybody credit if they submitted it, so that I can't do until I get back to my office today. That first quiz is over module 1 and 2. That's due by the end of the day today. So you got those practice problems. When looking at it, there's a couple questions where there's some issues. So I think a couple of them, it was defaulting to the first option, even though that wasn't the correct answer. So you're looking at your scores. You can't look at your responses yet. You'll be able to once that due date passes. Once the due date passes, I'll kind of update those questions. And there was, I think, one or two. I think there's two of them where the allowance on your rounding was supposed to be 0.2 and it was entered in as 0.02. So some of the rounding was causing some incorrect, to be scored incorrect there. So I'll fix those as well once that due date passes. So you should see those scores reflected accurately on Canvas tomorrow once that due date passes and I adjust those questions. Okay. We've got that daily quiz today, which once again, don't open it up until we start covering it in class. But we'll kind of go through that. The only other thing we have is that module 4 reading. So I expect to go through the first 10 slides or so for module 4 today, but that module 4 reading isn't due until we start class on Monday. Okay. So I think that should cover all the housekeeping stuff other than add this in here. So I didn't want to do this before we started class today. So you should now under module 3 kind of see this first Canvas discussion. So I give you a link here and it goes to a BLS table where you can look at the price changes over time in different products, right? Kind of put them on the graph for you. So as you read through this, I've given you 3 topics / prompts / questions that are related to this link, to the chart in this link. What each one will do is it tells you to use that link and then upload it to your generative AI tool of choice and then prompt it with the following question. Once you do that, it'll give you the output, right? It'll kind of tell you what it thinks the answer is to this question. You will then summarize and state what AI told you, right? Usually this is rather lengthy discussion, so you're just needing to summarize and answer the original question in the prompt. Or sorry, you're not answering it, you're telling me how AI answered it. And then there's some follow-up questions. In this one, does it match what you had thought looking at the graph yourself? Why might the largest dollar increase for this good not tell you that it experienced the most inflation? So every time I give you a prompt and you get some AI response, there will then be some follow-up questions, right? Where you evaluate the answer that AI gave you and why it might not line up with everything we talked about in class. So to earn the full points from your original response or post to this, like my original kind of questions, you will need to just choose 2 of the 3. So you will use, 2 of the 3 prompts to put them into your generative AI tool of choice. So if this is ChatGPT, Copilot, Gemini, whichever one you choose. You will then kind of report the answer and then answer some of these follow-up questions. So each of those, you're responding to 2 of the 3. Each one is worth 5 points. So a complete answer means that you state or summarize what AI told you and then responding to the subsequent questions of that topic, right, or bullet point. Once you do that, you will need to respond to 2 other students. So whatever they responded, they gave their generative AI's response and their questions, or sorry, their answers to the follow-up questions. You will compare and contrast your answers that you got. So you're looking for at least, one student that chose one of the same topics that you did and compare your AI's response to theirs and then kind of your follow-up, answers to the follow-up questions with their responses to those follow-up questions. You need to respond to 2 other students' posts, each one worth 5 points, that making a total of points possible on this assignment of 20. 5 for each of your kind of initial AI prompting and follow-up questions. You're choosing 2 of the 3, so 10 points there. And then 10 points, you're responding to 2 other students, each one worth 5 points. Okay. So that I have set, excuse me, to be due by the end of the day, Wednesday. I would suggest getting on and getting this done as quickly as possible. It gives more responses for everyone to start responding to each other. And also, our first exam is going to be next Thursday. Okay, so getting this out of the way so you can start to think about next week, starting to review for that exam. And I'll mention how to do that at the end of class today. But this is going to be our first Canvas discussion or posts. So other than that, I don't have anything else to mention before we just jump back into where we're at in the slides for Module 3. Have any other questions before we get started here today? Okay, so we left off, I think I showed you this graph. So we were kind of having this discussion of how we calculate real GDP using nominal GDP and GDP deflators. All right, so this is really just 2 different versions of the same equation. And then we kind of talked about if I determine nominal GDP, how do I use that GDP deflator to calculate real GDP? Or how do I use nominal and real GDP to actually come up with that GDP deflator? So just to kind of revisit this topic, right? What we want to think about is, okay, so we said anytime I'm looking at the base year, right? So we said that GDP deflator is equal to 100 times that ratio of my nominal to my real GDP. Okay. So if I'm thinking about in the base year, well, remember, nominal GDP was my current prices times my current quantities. Real GDP was using my base year's prices, but my current quantities. Okay. Excuse me. So if I'm ever thinking about the base year, well, the current prices and the base year's prices, if I'm looking at the base year, those will be exactly the same, which would mean that this is going to be 1. So my GDP deflator in the base year is always going to be 100. Okay. Now, in general, if we have inflation, which is what we typically see, what's going to happen to my GDP deflator after the base year? So after the base year, once again, I'm thinking about, I've now got my nominal and my real GDP. So here I'm thinking about, here's my current prices and quantities. And then to calculate my real GDP, I'm using the base year's prices and the current quantities. If I rearrange this a little bit, right, what this is saying is I would take, well, this cancels out. So really my GDP deflator is my relative prices in those 2 time periods. Another thing we talked about, what measures prices overall. You think about my current CPI or the year I'm looking at, that CPI minus the CPI of my base year. So if I ever have inflation, I know that prices have increased. So if prices increase, that means the price in my current year is larger than the price in my base year if I have inflation, right? That means prices are increasing, in which case this fraction would have to be what? Greater than 1. So I know that if I'm ever looking at my GDP deflator in any time period that's after my base year, if I have inflation, that GDP deflator will be greater than 100. Okay. Now, if I rearrange this equation a little bit, that would also mean, I keep this over here, that if my GDP deflator is greater than 100, when I'm calculating, sorry, I'm trying to get this to be on the same, there we go. if I'm calculating real GDP, that's my nominal GDP over that GDP deflator. Okay. So if my GDP deflator is greater than 100 here, and I think one of the things that I left off here, technically to be correct, I'm also multiplying by 100. So here, if this denominator is greater than 100, right, I'm dividing by a fraction that's, or sorry, I'm multiplying by essentially a fraction that's less than 1. What's going to be true is my real GDP will be less than my nominal GDP. Okay. So any time period I'm looking at past the base year, if I have inflation, my real GDP will be less than my nominal GDP. Now, if that's not the case, if I instead have deflation, right, I can think about here my relative prices, so the current over the base year. If prices are decreasing, that means that this numerator is now lower. This fraction is less than 1. So if I'm thinking about my real GDP, my nominal GDP, and I'm now kind of dividing by this GDP deflator I can think of this as now less than 100. So this is going to be, 99 or something less than 100 times 100. This fraction is now greater than 1, which would imply my real GDP is now greater than my nominal GDP. So if I have deflation, that real GDP in the subsequent or the next time period will be less than my nominal GDP. Okay. Now we can see this, right? If we make these calculations using actual values, when I'm looking at this table, right, what must my base year be? Well, in my base year, the GDP deflator is 100. My prices I'm currently using are the same as my base year prices. My GDP deflator should be 100, so we have the base year here being 2012. Notice that because in practice, we typically see inflation across all time periods, that when I'm looking at years past my base year, my nominal GDP ends up being greater than my real GDP. So I've got inflation after the base year. It always ends up being that my nominal GDP is greater than that real GDP. Now, it gets kind of weird, but if I had deflation, the opposite would be true. But if I'm working backwards in time, if I have inflation, when I go backwards, I'm actually looking at lower prices. So it's almost like looking at years before the base year, I'm actually thinking about there's deflation. Technically, there's not. It's just that we're looking back in time, right? And so if I have inflation over this time period, going backwards, it's actually like prices are going down. So in every year prior to the base year, if I have inflation, the exact opposite holds. My nominal GDP actually ends up being less than my real GDP. So if we were to kind of graph this out, we can see in 2012 that this is my base year, right? Because real and nominal GDP are the same. Every year past that, because we have inflation, that nominal GDP is less than our real GDP. And if we go backwards in time, that real GDP, right, ends up being greater than our nominal GDP. Any questions on that before we keep moving here? Okay. All right, so, So the next thing we're going to talk about is how we calculate growth rates. Okay, so we can think about real GDP as reflecting what the output of the country is, right? So higher real GDP generally reflects that we have higher output. Because remember, we're looking at real GDP, we're concerned with changes in output, so we're controlling for prices. So our growth rate as a percentage is going to be the change in real GDP divided by the original GDP of the year where we kind of started out. So if I'm going from 2024 to 2025, what was the change in real GDP divided by my starting GDP, which would be that GDP in 2024. To get it as a percentage, we multiply by 100, right? So we can actually look at a table like this, and we can do the math to figure out what our growth rate was. So if I'm trying to calculate growth rates here, and I'll just use Excel to kind of do this math for us. So here was the kind of Excel file we're actually going to use for module 4. We're not using that yet. I'm just going to use this to do our math. So if I'm looking here, if these were my nominal and real GDP values, how would I then calculate the growth? Ooh, I can spell the growth rate, right? Well, the growth rate is always going to be 100. I'm trying to make it as a percentage times what's the difference in my real GDP? I would take 2025 minus 2024. That's the change in my real GDP. And then divide that by where did real GDP start out at? Well, the kind of older time period here was 2024. So here I had a growth rate of 22%. Okay. Questions on that idea before we keep moving? Okay. So something else I just wanted to point out here is when we were looking at inflation, how are we calculating inflation, right? So if we wanted it as a percentage, we said we'll take 100 and multiply that by. Now we're using the CPI, but if we're thinking about just any one good, what we had was we're taking whatever the new prices are, like the newest time period, minus whatever our old prices were, and then we divided by where did our prices start out, or what were the prices in the old time period. Well, notice when we're calculating growth rates, it looks very similar, but instead of prices, we're actually using real GDP from the new time period minus real, I didn't leave myself a lot of room here, real GDP in the old time period, and then dividing that by wherever real GDP started out, or real GDP in my old time period. So very similar equations. However, inflation was measuring a percentage change in prices, but what did we hold constant? We held constant. We were looking at the same market basket, so we held constant quantity. What are we trying to do with real GDP? What we're trying to do is control for prices. So our growth rate, if we're using real GDP, should be the percentage change in output. But now, because we're using real GDP, what we're trying to hold constant are our prices, right? We know that in most cases, we've got simultaneous changes in prices and output. Each one of these measures is trying to look at each one individually. Inflation looks at percentage change in prices, holding the quantity constant. Growth rates look at percentage changes in output, holding prices constant. Okay. So if we go back here to our slides, right, we can kind of do this math, right? I kind of already showed you how we did that in Excel. So moving on from this idea, let's do something in our quiz for today. So I'm going to open up that June 26th daily quiz, right? That's what we're about to kind of work through here. So if we're opening it up right now, what we just talked about, and a little bit of it was review, but a question like this first one should be relatively easy. So if I'm looking at the base year, so 2015 is my base year, and 2020 is like the year I'm looking at after that. My GDP deflator of the base year will always be, and here I've got the answers, but we want to make sure we can kind of work through this, would always be 100, right? In that base year, my current prices are the same as my base year prices, so nominal and real GDP will be exactly the same. Okay. Now, for the second one, if we see that output has increased, right, and the GDP deflator is 95, what must have happened to my average prices? So I've got this GDP deflator, which is 95. What must have happened to my average prices if output or real GDP increased? So if I'm thinking about I've got real GDP is equal to my nominal GDP divided by that GDP deflator. And then we multiply this by 100. So anytime my GDP deflator is less than 100, in this case, we said it was 95. Even if we don't know what our nominal GDP was, right? Here, essentially, we can think about my nominal GDP is getting multiplied by 100 over 95. This fraction is greater than 1, which means my real GDP is actually greater than my nominal GDP. Okay. When will that be the case? Well, we can think about why that GDP deflator was less than 100. So if my GDP deflator is less than 100, we kind of had our GDP deflator is nominal over my real GDP. We already had rewritten this earlier. Nominal GDP is kind of my current price times the current quantity. Real GDP is my base year price times the current quantity. So anytime I'm looking at this, I could write this as quantity gets canceled out. So I've got the price in my current year over the price in my base year. If this is in fact, right, less than, if my GDP deflator is less than 100 here, or when would this fraction be less than 100? It would have to be, and I left out here, sorry. We're always multiplying by 100 here. So when would this be less than 100? It would have to be that this fraction is less than 1. What's the only way that's possible is if my current prices are in fact less than the base year, which means that my prices must have decreased. Okay. So you could also just memorize kind of that rule of thumb. If real GDP is ever greater than nominal GDP, we must have deflation, or we're looking at price decreases. Okay. Any questions on that before we keep moving here? So in the second example, we were given nominal GDPs, we were given GDP deflators, right? And we want to know what's the growth rate. So I could kind of write this out. I'm going to actually use Excel, and we're going to change the view here so we can see things a little bit better. Just so that we can grab these values. You could do this by hand. I think it'll be a little bit easier here so we can see the intermediate steps a little bit better. So here I've got 2024, 2025. My nominal GDP values are 500 and 550. In each of those years, my GDP deflator was 110 and 122. So notice here, my GDP deflator is increasing, which means I must be having kind of price increases, or I've got inflation. Okay. So, or it's greater than 100% of inflation. And so if I wanted to calculate real growth rates, right, I need real GDP. So my real GDP, we said, is take that nominal GDP, divide it by that GDP deflator. Now, we also had, I would then multiply that by 100. Okay. I would do the same thing, right? I don't even have to drag this down. I could show you, right? We're just taking nominal GDP, dividing it by my price deflator, and multiplying that by 100. So I now have my real GDP values. Okay. If I then wanted to calculate my growth rate, what I would do is I would take, now the equation I had in the previous slide was growth rate as a percentage. This problem, I'm just asking for the growth rate. It's not asking for it in percentage form. So we're just going to calculate this without multiplying it by 100. So how do we find a growth rate? It's the change in my output, or real GDP. So I took the new GDP minus the old GDP. I then divided by the old GDP, which notice here, anytime my real GDP has decreased, then my growth rate is actually negative. So once I hit enter here, sure enough, I see that I've got a growth rate of negative 0.008, or, all right, if we round this to the second decimal, negative 0.01. Let me make sure I had these values in here correct. We took nominal, oops. Oh, these are the ones so we have nominal over the GDP deflator, nominal over the GDP deflator. Yeah, so we should have what? Negative 0.01 here. We round to that second decimal. Now, if I wanted it as a percentage, right, then all I would do is multiply that by 100. Okay. Any questions on this idea before we keep moving? Oh, take this out of the quiz. Well, hopefully we kind of had those responses. We can kind of get those entered in here. All right, so we said what? Exactly 100 and decreased. And I had 0.01. Actually, it looks like these might have gotten flipped. So I'll make sure I give everyone credit as long as you're kind of submitting an answer to this. When we worked through the math, right, we ended up with what? Negative 0.008 or negative 0.01, not 0.10. It was supposed to be 0.01. All right, so I just wanted to kind of make sure we had an example where we could kind of work through the math here. Any questions on that? Make sure you're getting that submitted if you open it up to work along with me. All right, so the next thing that we'll do is think about looking at these growth rates. What do they tell us? So if we're looking at our growth rates, right, if we have negative growth, like the example we just had, what that means is when we're using real GDP, we've already controlled for prices. So real GDP, if we're using that to calculate growth rates, should reflect that we've seen decreases in output or what we would call contractions or recessions in our economy, right? These are a bad thing. That means that controlling for prices, we've actually seen output go down. The general rule of thumb is if we had growth rates below 10%, we would kind of call this a depression, right? It's an extreme recession. Okay, so it's like a subcategory. And then if we ever have growth rates above zero, then we would say that we have expansion in our economy. Right? And I kind of already mentioned this, but if we have recessions, that means output's going down, or we have negative growth rates. If we ever have expansion, right, we have increases in output, our growth rates will be positive. Okay. So we start to kind of think about these things. If I were to look at some data, some actual data, you'll notice, well, over time, we've got positive growth rates. Sometimes they become negative. So there aren't as many recessions here. There's a couple years in which the growth rate barely dips below zero. So there are time periods where we have short-term real GDP decreases or short-term negative growth rates. But over time, it remains, quite a bit. It's above zero. So we generally have positive growth. Now we have one extreme example here, which is, why did we see such a sharp, you could even call this a depression, right? Or a very, small time period where we had a depression. But why were growth rates in 2020, highly negative? Well, we had COVID. A lot of things shut down. Right? So I also want to kind of use this to point something else out. Anytime I have a recession or negative growth, we then saw a huge spike, right, in the subsequent year in our growth rate. So why is that the case? Okay. Well, if I think about how I was calculating growth rates, right, we said our growth rate, if I don't do this as a percentage, just to kind of to use this. So I had real GDP, for example, in, I could think about 2020. I then had my real GDP, 2019, divided by my base year, which was GDP in 2019. Well, if the change I saw was strongly negative, right? This growth rate was, less than zero, but it was like, I don't know, negative 20 or something like that. Well, when I calculate the growth rate for the subsequent time period, right, I'd now be looking at real GDP in the current year minus the real GDP in the prior year, but I'm dividing by the old year's GDP, right? Well, anytime I see a huge decrease, right, or negative growth, this GDP value is now going to be much lower. So even seeing the same change from 2020 to 21, because that base year's GDP was significantly lower because of that recession, every time we look at a year right after a recession, we're going to see a relatively large growth rate because it decreased this denominator, meaning the same change in real GDP is now going to cause even larger growth rates. So when we're looking at this graph, that's why we see like when we have extreme recessions, they're generally followed by extreme growth. Similar kind of idea here. We had extreme, not extreme, but we had a recession. The response is then that denominator is smaller. We then kind of see a response of relatively large growth rates. We could even look at this a little bit further, right? So if I'm looking at a smaller time period, we will kind of define any time that we see GDP growth kind of hit a maximum point, we would call that a peak, right? So once it starts to decrease, whatever point we were at that had that largest growth rate before the decrease, we would call that the peak. Once we get to the lowest possible growth rate and it starts to increase, we call that point where it starts increasing our trough. Right? So this will occur, over time, over and over again. So notice right here, once it starts decreasing, that's another peak. Here would have been a peak. Here's another trough. So we kind of see this cyclical nature to our economy. Right? So we see, we go through recessions. We then kind of see expansions, et cetera, et cetera. Now, these are like broken down by quarters. When we look over longer periods of time, although we might see week to week real GDP go up or down, we're generally more concerned about, well, what's happened to real GDP over the course of the year. Okay. Any questions there before we keep moving? Excuse me. All right. So what are some limitations of using nominal or real GDP? Okay. So we'll kind of have this example where let's say I was looking at nominal GDP values. We'll just start out with nominal. We know there's an issue there because we haven't adjusted for prices, but I'll kind of highlight this in a little bit. So if I've got relatively large GDP in one country relative to another, well, why would we expect China to have a significantly higher nominal GDP? Even if prices were the same, they have way more citizens, right? So if we have way more people, right, more people are working, we're going to have larger amounts of wages being paid, consumer spending is going to go up. These components that we use to calculate GDP, no matter if we use the income or expenditure approach, when we have more individuals, we're going to see output just be higher. Right? So China's population is significantly higher than Switzerland's. But if I just use nominal GDP, I'm like, oh, China's economy is way stronger. So what we want to do is account for the fact that China has a significantly larger population. Right? So the measure that we'll use to compare across countries is essentially we want to know how much output is each person in the economy producing. And so we're going to use not GDP, but GDP per capita, right? Dividing that level of output by population. So if I look at GDP per capita values here, take GDP and divide it by the population, well, now I get a pretty strong opposite conclusion. If I look at GDP per capita, China's is significantly lower than Switzerland's. So if I'm using this more accurate capture of GDP, how much each person is adding to GDP, it looks like Switzerland's economy is doing better. So just kind of giving another like example where we have some slightly smaller kind of numbers, easier numbers to deal with. Let's say I have I want to be looking at nominal GDP, and I'm looking at the US and I'm looking at Canada. Right? So the US here, I'm going to have 1,000 as their nominal GDP, Canada 100, right? Easy numbers to deal with. If I just use nominal GDP, it looks like the US has a stronger economy. However, if the population in the US is significantly larger than in Canada, when I calculate my GDP per capita, right, or I divide GDP by the population, then what I end up seeing is for the US, I get what, 50 here? Right? And then for Canada, I get 100. Well, then here it looks like using GDP per capita, the country that actually is having a stronger economy is Canada. Okay. So just another example with some more simple numbers, but I'm using these for a reason because we're then going to talk about, so I went through this example, why nominal GDP is misleading. We need to kind of divide that or account for population. But why is nominal GDP per capita still not really a good measure of how to compare across countries of how well their economy is doing? Well, nominal GDP per capita only controls for population. It hasn't controlled for prices. So what do we actually want to do? We want to use real GDP, right? So we want to use real GDP per capita. So why is this the case and how could this change our conclusions, right? So if we have the same setup, right, let's assume instead that if we had information on prices, we calculate the GDP deflator in the US and Canada. Let's assume that the nominal GDP, right, if we turn those into real GDP values, maybe Canada is experiencing significantly higher inflation, so their nominal GDP was being impacted more by these higher prices. So once I calculate real GDP, let's say the US and the Canada have 900 and 200 as their real GDP. When I then look at real GDP per capita, my population numbers I'm going to use are still the same. So 900 over 20 gives me 45. 200 over 5 gives me 40. Now, that nominal GDP per capita wasn't actually correct. It was telling me the US had a kind of weaker economy than Canada, but once I've used real GDP and look at real GDP per capita, now it looks like the output per person controlling for prices is actually higher in the US. So if you're given nominal GDP values and population, if I had things like the GDP deflator, I could convert those into real GDP, look at real GDP per capita, and this is the measure we want to use when we're comparing across countries. Okay? So where are we on time? Okay, perfect. Any other questions on this before we keep moving here? See, I've lost quite a few of you today. Hopefully hopefully there's a lot of people going back and gonna watch this, right? So the next thing we're gonna do, I've got kind of this Excel file from Module 4 pulled up. We're gonna jump into those Module 4 slides. So I'm just gonna start this from the beginning. Okay. So Module 4, we're gonna use real GDP. We're gonna think about how we calculate growth rates, and we're gonna look at long-run growth of an economy. Okay. So we already talked about this idea. So this is once again, every module, we're going to be, using stuff we talked about from previous modules or the material is comprehensive. So we said in the prior class, every economic exchange, right, there's a circular flow to our economy. So every time somebody buys something, someone is going to be receiving money. So when consumers purchase goods, they're spending money on a product. That was our expenditure approach. But the producers, we could also think about, might incur costs to produce those goods. That would be the expenditures that they're making. Now, when employees are working for a business, they're receiving wages, and then businesses are able to receive output from employees. That is our essentially income. So anytime we see, an expense, it's always going to be matched with income by somebody else, right? Or a benefit to somebody else if it's easier to think about that way. So with this idea of economic production, right, we then want to think about, let's say I have an economy and I'm measuring their output of, I could look at two goods. Here I chose an example where we're looking at the output of goods and services. So what this would represent is if we use every resource in our economy, this is the different combinations of goods and services that we can provide. Here we've chosen to produce these two amounts of goods and services. So this hopefully will look familiar from B251 if you've taken that course. I'm not sure who you had for it. If you took me, you literally would have seen this exact same graph, where we can think about this as what we call production possibilities curve. These are all the different combinations of these two goods using all of our resources we could produce. Right? So what happens if we have a technology change? Well, that means that using the same resources, even if I have the same number of workers, if I now give them computers, they can be even more effective than they were before. So even having the same number of resources in my economy, I can get higher levels of goods and services. Also, if I'm just strictly measuring output, right, we're not looking at output per capita, growth in our population, we now have more workers, if we want to think about it that way. Using the same resource, I have more workers, I can produce more goods and services. And then technology changes, very similar, or they would kind of cause these changes in labor productivity. But if I have new technologies, my labor or my capital, my machinery are going to be more effective at it than before. So you're going to have the same number of workers, same number of computers. If I have a new software program that would make both of them more effective, what this essentially will do is now using all of my resources, any change in one of these three things means I can produce higher combinations of these two goods. So I'll kind of see this shift outward in our production possibilities curve. Okay. So with this idea in mind, right, if we see an increase in our production possibilities curve, essentially what this is reflecting is economic growth. So everybody used to be quote unquote poor, right? If we go back in time, real GDP or the production levels of countries was much lower than it is today, right? Over time, most economies expand, right? Or we have expansion. We have growth rates that are above zero. Now, we talked about, we still might see short-term recessions, right? Short-term negative growth rates. But over time, we've seen all countries really experience growth, right? Or expansion. So, if we want to look at different countries, and here I think they group these, and this is going way back to 1820. If I'm looking at kind of GDP, real GDP per capita, it was low for every country back in 1820. Over time, all of these countries, they've seen increases in population, technology, effectiveness of workers and machinery or capital. All of them have experienced increases in their GDP per capita or have experienced positive growth. Some more than others, right? This is pretty dramatic increases in a lot of these countries. But here, this kind of really is a good visual depiction of they've all experienced positive growth rates. Okay? So how do we calculate economic growth? Well, what we should be looking at is percentage changes in my GDP per capita. And I'm being a little bit lazy here. Everything we look at from here on out, I really should be looking at real GDP per capita. Okay? So from here on out, we know that real GDP is the preferred measure. So we're looking at the change in real GDP per capita, right? What real GDP per capita is in the current year minus the old year, and then dividing by that base year. So you'll notice here, when we're using growth rates in this module, unless you're specifically asked for them as a percentage, we are just using the decimal form of the growth rate. Okay? So we're not multiplying this by 100, we just want that decimal form. So long run growth, if we have positive growth rates, should reflect an increase in a country's standard of living. Now, this doesn't have to necessarily be the case in the short run. We already said in the short run, we can see these kind of minor recessions. But for all countries over the long run, they all saw positive growth rates. Well, who experienced the largest growth rate, right? We want to be able to compare across countries. Okay? So controlling for population, controlling for prices, that's why we're using the real GDP per capita measure. So let's say I had this data, right? And I've got nominal, real GDP. How can I calculate these growth rates? Okay. So let's just grab these numbers, which I already did here in that first tab of that module 4 Excel file. I'm going to zoom in a little bit here. So let's say I didn't have these values. How can we reproduce them? Okay. Well, my nominal growth rate would simply be my current GDP minus the old GDP, and then dividing that by what the old GDP was, or kind of where I'm starting out. Now, here I will kind of change this. This is nominal GDP over here, so this would be calculating my nominal growth rate. If I wanted to display this as a percentage, anytime we're calculating these growth rates, we can always convert a decimal form of a growth rate to a percentage by simply multiplying by 100. Okay? So this gives me, that's how I was coming up with that 5.35 growth rate. So just to kind of make sure this is clear, and I'll update the Excel file after class so we have this. Here was my nominal GDP. Okay. Now, if nominal GDP doesn't control for prices, then if I have inflation, my growth rate will capture growth in output, but also growth in prices. We don't want that, right? I know that if prices are going up, I'm always going to see larger changes in my nominal GDP. So I actually want to use this real GDP. And if we had more data, this is more of a simple example. I would really want per capita data. But here, this is going to like highlight the difference between nominal and real values. So here, if I want my real growth rate, I would take the current real GDP minus the previous year's real GDP, divide that by where real GDP started out. If I want it as a percentage, I'll multiply by 100. I see that surely enough, when I use real GDP, my growth rate is significantly lower. And that's because when we have inflation, like we typically see over time for most countries, nominal GDP captured some of that price increase where real GDP is holding constant prices. Okay? So anytime I have inflation, my nominal growth rate will be greater than my real growth rate. On the flip side, what would be true if prices decrease? Well, if prices decrease, that lowers my nominal GDP, but it doesn't impact my real GDP. So there, if I had deflation or decreases in prices, there my nominal growth rate would actually understate what the real growth rate was. So the exact opposite of the example that we have here. Right? Now, if I wanted to, I think in the slides I have a question, what must inflation be? Well, similar to when we're looking at real and nominal interest rates, my real interest rate was my nominal interest rate minus inflation. So if I've got my real growth rate, right, and my nominal growth rate, it should be that my real growth rate is nominal minus inflation. Well, if I know the real and the nominal growth rate, I would rearrange that equation a little bit. So the difference between my nominal and my real growth rate should be inflation, right? Because nominal growth rate captures changes in prices and changes in output. Real growth rate is only changes in output. The difference between the two must have been inflation. Okay. Any questions on this idea before we keep moving here? All right. So I then have in the next slide the exact same values, but I'm saying, okay, what if we had growth rates, we have GDP values, but I don't know what GDP was in 2024? Okay. How could I calculate what that is? Okay. So if I'm looking at these values, we're going to think about how would I do this just in general terms. Okay. So if I'm looking at my growth rate, and here we're going to look at growth rates not as a percentage. Okay. So my growth rate is going to be, and here I think I asked you about nominal values, so we're calculating nominal growth rates. So I'll have my nominal GDP, and I'm going to shorthand this a little bit, but we're talking about GDP. So nominal GDP in 2025, nominal GDP in 2024, and then we're dividing by that base, or I shouldn't say base year, that starting year of 2024. Okay. So if I know my growth rate and I know my nominal GDP in 2025, how could I solve for my nominal GDP in 2024? Well, it shows up twice, so I've got to do some rearranging of this equation so I have an equation that's just in terms of nominal GDP in 2024. So I'm going to multiply both sides by the nominal GDP in 2024. That would cancel this out, and I would have my nominal GDP in 2024 times, and I'm just going to abbreviate this, whatever that growth rate was. All right, so here I'm abbreviating this. Now that's going to be equal to the difference in my nominal growth rates between these two time periods. Well, if I'm wanting to solve for this, I need to keep on doing some work here. So I'm going to add this to both sides. What I'm now left with is my nominal GDP in 2024 plus my nominal GDP in 2024 times my growth rate should be the nominal GDP in 2025. Well, I can rewrite this. I've got nominal GDP in both of these. I could rewrite this as my nominal GDP in 2024 times 1 plus that growth rate. That should be my nominal GDP of 2025. Remember, the original question was, what is this value? So if I want that, I divide both sides by 1 plus the growth rate, and I get that my nominal GDP in that older time period was my nominal GDP in the current time period divided by 1 plus that growth rate. So hopefully this equation holds, right? So if I look here at our example, if I didn't know what my nominal GDP was in 2024, but I know the growth rate and I know my current GDP, we just said, how should I be able to solve for that? It should be the current nominal GDP divided by 1 plus my growth rate. Now, the problem here is, and the point I want to make, is that if I do this, I should get 29,000. Oh, what went wrong? When we use this equation, we don't use the percentage form of that growth rate. We use the decimal form. So what should I really be doing? Making sure I divide that by 100, or I should be using the value of 0.0535. So I can divide it by 100 as an equation, or I can convert it to my growth rate as a decimal form. And now I've got, I can use this value, which with the decimal form, that should give me the exact kind of same value. Now here, this is a little bit different because I rounded this, I entered it in. Technically, I should have been taking this, right, and dividing it by 100. There, that would give me the same values. So when we're calculating nominal GDP given growth rates, where we don't know one of the time periods nominal GDP, we need to make sure we're using that growth rate in decimal form. Okay. And then, we could do other missing pieces as well. So we'll do a different example. Let's say I had the real GDP in 2024, and I know the real GDP growth rate. Well, if I'm rewriting what we have here, a general form of this equation, if I rearrange this, my GDP, whether or not my GDP, whether or not I'm using real or nominal GDP, will always be my current GDP would be equal to my old GDP times 1 plus, right, moving it around, that growth rate. So if I ever know my old GDP and I know the growth rate, I can calculate what my current GDP is. Or if I have an expected growth rate and I want to predict the following period's GDP, I could take the old or the current GDP and then multiply it to get that following year's. Right? So this is the equation that we would use to calculate what the GDP would be in the following year. So notice here, if I start out and I know my original real GDP, if I multiply that by 1 plus the real growth rate, now once again, I need the decimal form, so I'll divide it by 100 here. This should give me the same value as the subsequent year's GDP, and sure enough, it does. Okay, so we can kind of work in either direction then. All right. Any other questions on this before we keep moving? And I know sometimes if my writing gets too or if it's not legible enough, you can't read it, make sure you're asking questions here. All right, so the next thing we're going to go through is think about, we just said we can make predictions for the real GDP for the upcoming year if we have expected growth rates. So if I want to make projections 20 years out, I can use a very similar form of that equation. My new GDP will be the old GDP times 1 plus the growth rate, but that growth rate, if it remains constant for 20 years, you can think about it's going to be getting multiplied by 1 plus the growth rate times 1 plus the growth rate year after year after year. This would be the equation that we could use to make predictions for any number of years. N is the number of years out we want to make this prediction for. Or if we have an actual growth rate, it's how much our GDP becomes in 20 years. Okay. So here, once again, we're using the growth rate as a decimal. If we had a percentage, we would simply convert it to a decimal by dividing by 100. So here I wanted to kind of go through an example where, we've got relatively low growth rates. We want to calculate what new real GDP will be in 20 years. The starting GDP is 100 or 100 billion, right? To make it line up with probably numbers we'd be more likely to see in practice, right, in the real world. So I've got this in the Excel file as well, right? Now I'm going to add something in that the Excel file doesn't have. So I'm going to blow this up, right? So I've got my old GDP, I've got the number of years, and then I had this already entered in here, but I'm going to change this a little bit, okay? So I'm going to get rid of this for a second. And I want to calculate my new real GDP 1 year from the current. Well, if that was the case, then I said the equation we had was take my starting GDP of 100, multiply that by 1 plus my growth rate, right? And that would tell me the real GDP in the following year, after 1 year. Okay. I would then do that for each of the next 2 different growth rates. So if I drag this across, I want that initial starting GDP to be the same. And I want this to show what would be the changes in my new real GDP at these different growth rates. Well, notice as the growth rate is increasing by 1% here, in the following year, that only increases GDP by 1. Like every time it goes up by 1, it only increases GDP by 1, or a relatively small amount. However, so we didn't have essentially what we would end up calling compounding growth rates. Well, then in 2 years, it should only go up to 104, and in 3 years, 106. So if I had a 2% growth rate and I had 20 years, we might think it only goes up by 40. But because it's compounding, if we're making that prediction for 20 years out, it's going to be our old GDP times 1 plus that growth rate, but to the power of however many years we're trying to project out. So I would kind of use dollar signs here because I want to freeze these cell references. So when I copy this across, it's using the same starting value, same number of years, but making predictions for different growth rates. So notice here, over 20 years, 2% growth. Instead of going up by 40, it goes up by 48, right? It goes up even larger. And then as growth rates increase, notice what starts to happen. Well, a 1% increase in growth doesn't just cause real GDP to go up by 1 or 1 times 20, right? Because if I had 20 years, it goes up by 1 every year. We might think it goes from what, 148 to 168. But in fact, it goes all the way up to 180. Right? And if we keep on going, now it goes up to 219. Right? So even that same change in the growth rate produces significantly different real GDPs, right? Or the difference in these GDPs is much larger if that growth rate continues more than 1 year for, the next 20 years. And then we could play around with this, right? If I went out to like 50 years, those differences become even larger, right? So that's the idea that what we would call, have this kind of goofy, oh, there we go. So I have kind of this goofy meme, right? Don't underestimate the power of compound interest. So when we're talking about growth rates, something you might have talked about, and if you've taken a finance class or other courses you've taken at IU, it's this idea of compounding interest. So this is why you don't want to have a high interest rate on a credit card, because if you don't pay it off, it increases significantly year after year. Same kind of idea, it's just on the opposite side. If we have growth rates, well, we love higher growth rates because even significantly small growth rates over time, right, they compound. So we have compounding growth rates, just like we have compounding interest rates. It's just that compounding growth rates are really good for economies. Okay. So I'm going to hold off on this. We'll pick up with this on Monday's class, just to kind of review what we're talking about here with compounding growth, and revisit this idea. We'll then kind of transition to talking about factors that impact long-term growth. I think that we should be able to get through all of the material, the remaining material for Module 4, by the end of class on Monday, if not all of it very close. So next week, we'll finish up Module 4 likely on Monday, or it's going to have a little bit of spillover onto Tuesday's class. So that means that not only would Wednesday's class be for review next week, but Tuesday and Wednesday's class will primarily be for review. Now, the second quiz won't be posted until after class on Monday. It'll then be due by the end of the day on Wednesday, the day before the exam. I would suggest trying to get it done sooner rather than later. We obviously won't have covered all the material until after Monday. So just kind of putting that on your timeline, manage your time accordingly. Now, I would also want to mention that once you take that quiz, you'll be able to see the answers. Now, when I'm doing review in class, because not everyone has done the quiz, I'm not going to answer any questions that actually come from that second quiz. The questions I will work through, if you have questions and you show up live, ask questions on the old practice problems for quiz 1, practice problems for quiz 2, which that could help you both for quiz 2 and that first exam. And then any of the questions we have from the first quiz, once you can review it after this due date passes, those would be questions to ask as well. Once I get through everyone's questions, I'll probably have a set of questions or think of some off the top of my head that I know look maybe similar to that first exam's questions. And we'll just be basically going through more problems and doing review in those 2 class periods. Once again, Tuesday we might have a little bit of spillover to finish up Module 4, but I think we should get through the bulk of it on Monday's class. Okay. Any questions from the couple of you who have hung around here today? All right, so I'm going to stop the recording here. Oh, maybe, there we go. And I think I stopped it. Nope, I hit the wrong button. There we go.